Hello everyone, it's Cyanel and today we will see a little update about my computer. So, you have two new peripherals. One is this input panel to input some numbers when a core needs it. And here is another type of memory to deal with some sorting algorithm. So, let's see an example. So, let's begin with some inputs. In this core, I have an algorithm to request data and store them into this memory. So, here, when the core needs a request, it will request it to the main bus and to the connection with this panel. Here, you can see that one core needs an input, and the core number is the number 2. Let's input a value, 6 for example. You press this button, and then the core will continue to run, and soon need another input. So you see this lamp on. Let's accelerate the game. So another input, let's input for example 7, sorry. Then another one, let's input 5 and 4 for example. And now I want to stop. So in this algorithm I code that 0 stop the request, so I put 0. Now we can see these inputs in this memory. So you have here 6, then 7, then 5 and 4. Oops. Now we want to sort this value. So let's initialize this core. It will run until that all value in this memory is sorted. This algorithm is a bit slow because it needs to do a lot of access to peripherals, and this access is not optimized in time, but to remember, this main bus is optimized to allow a maximum of peripherals. So it's a bit slow, but it does the job. Now it's finished. So let's reset the right time and see in the memory. You have now 4, 5, 6 and then 7. So let's see now some specification about these two parts. Okay, let's begin explanation with this inputs panel. So you have two parts, the blue parts and the lime part. The blue part is for sending data. You can see here you have 8 bits of value, and the blue parts will convert this 8 bits into a single line sequential signal. And that way, on the other side, on the main bus, you have a decoder to decode this sequential signal into 8 bits again. In fact, it's 11 bits because we need extra data, but anyway. The other part is this lime circuit that comes from the main bus, a request here on this line. The request is, again, the sequential signal is decoded in this 3-bit lines, and you can here store up to 4 requests at the same time because you have 4 core, and that way we don't lose any request. The request is displayed here, and you can't send any data until this lamp is on, because I don't want to miss a data and send it to the main bus, because the main bus buffer will store them, and after that will release, and we don't want this. So it's a security. So here is these 2 parts. Of course, on the main bus side, you have the exact opposite things. That means here, when we send a value, the value is decoded here with this little decoder sequential to lines, and here we have a little encoder to encode into a sequential signal the request of the core. It's not really complicated, but it's, I think, the simplest way to do an input peripheral inputs panel. Okay, let's continue with this part, that is the memory that I use. I don't want to go deep in details, but I can do another video for explaining precisely how it works. But basically it's a memory. It's here you have 7 bytes, but of course you can add more, and of course add more delay, so it's a compromise. And it's a queue. So the queue is equivalent in terms of algorithm to the lists. So you can run different lists sorting algorithm with this queue memory. You have different operation, but with some type of operation, you can do exactly the same as you can do with a list. So for this algorithm that I show you in the first part of the video, I use this one, and each value is stored in this memory here, and you can store them. A little thing is that in this design, the 0, you can input 0. So if you input 0, it counts for 1 value. It's, I think, important. So that's it for this video. I hope you enjoy, and see you soon. Bye!